Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi classes YouTube channel where we inculcate interest and confidence in physics subjects. Today we'll remove your doubt and confusion and discuss one probable board examination pattern, cells in series, and we'll find out one equivalent cell EMF and internal resistance for a combination of several cells in series. If you won't devote next 5 minutes on this learning video and may found the same question in board examination, then won't say you left behind. फिर ना कहना रह गया. In our board examination, we are given n similar cell, each of EMF E and internal resistance small r, and they are connected in series. We have to find out what current they will send in an external resistance R, and we have to also analyze conditions for which this cell combination is effective or ineffective. So here n identical cell, each of EMF E and internal resistance small r, are connected in series to an external resistance capital R, and to analyze this circuit we can find out single equivalent cell EMF and internal resistance for this series combination of several cells. Equivalent EMF for a combination of several cells is defined as that terminal voltage which is obtained when cell is in open circuit condition. So we'll remove external resistance from this cell combination and will determine this terminal voltage in this open circuit condition. And in this open circuit condition, as circuit is not complete, no current will flow through cell combination, and in that condition there won't be any voltage drop in these internal resistances. In fact, all these internal resistances will become ineffective in current zero condition or in this open circuit condition, but the voltage of cell EMF will remain effective. And if we move from one terminal to another terminal, and we'll find that all EMF in additive manner will add in voltage rise, and we'll get for n identical cell, each of EMF E, the total effective EMF of this series combination as NE, as open circuited terminal voltage for this series combination. So that become a effective EMF of this n series connected identical cell of EMF E. So E EMF and n cell in series results in NE EMF. To find out effective internal resistance of this series combination of cells, we'll consider the passive equivalent circuit of this combination and we'll short circuit all EMF, and in that case we will find that all resistances of these cells are in series. So each cell got internal resistance small r, and there are n such resistance in series. So effective internal resistance of this cell combination will become NR. So we can say n identical cell of EMF E and internal resistance R will become a single cell equivalent EMF NE and equivalent internal resistance NR. And when this combination is connected to external resistance R, it is just like a cell of NE EMF and NR internal resistance is connected to external resistance capital R. When external resistance capital R is connected to n identical series connected cell combination of effective EMF N capital E and total internal resistance NR, then current in this external resistance is given as EMF divided by sum of internal and external resistance, and effective EMF is NE and effective internal resistance is NR. So total circuit resistance is N small r plus capital R, and voltage divided by resistance will become current in external resistance by the cell combination. And if we consider the current in same external resistance by a single individual cell, then it will be EMF divided by total circuit resistance. And now we can compare the two results. When we connect cell in series, both EMF and internal resistance become n-fold. Now effectiveness of this series connection in making current flow in external resistance depend upon the comparison of internal resistance of cell and external resistance. This series combination of n number of cell is least effective if internal resistance of cell is much more than external resistance, and in that case both EMF and internal resistance when become n-fold, and since internal resistance is much more than external resistance, in this sum if we neglect external resistance we'll get that current of n series connected cell combination is E by R, as n get cancel out for internal resistance very high compared to external resistance, and this current is same as current produced by single individual cell. So circuit won't produce higher amount of current in external resistance if internal resistance is much more compared to external external resistance. So this series combination of cells is not very effective when internal resistance of cell is much more than external resistance. This series connection of identical cells is very effective if internal resistance is very small compared to external resistance, and in that case when we add cells in series, effective EMF become n-fold. Also effective resistance also become n-fold, but this increase in internal resistance is small compared to external resistance, so current is approximately become n-fold as compared to current produced by a single cell. So when we have a higher value of external resistance, it is better to place cells in series, and for a smaller value of external resistance, to get higher current in external circuit, it is advisable to connect cells in parallel, because in parallel connection, though EMF won't increase but internal resistance will decrease, and that will result in higher value of current in external resistance. So for small external resistance, parallel connection of cell is advisable, and for higher external resistance, series connection of cell is better. We hope this beautiful learning video has removed all your confusion for this topic, combination of cell in series. Our other learning video of same confused in physics series are equally useful, and you can get notes of this problem and other important problem of this year board examination in a link which is given in description. If you found such study material useful, do use it in your study as well as share it to your friends. As you know, sharing knowledge enhance knowledge. Happy learning. Have a nice time. Thank you very much.